Well, as soon as we discovered that there was mirror neurons in monkey, we immediately tried to use some technique to demonstrate in humans. I think mirror system with non-invasive technique can be demonstrated by using brain imaging. That's fMRI and PET. By using neurophysiological technique like EEG and magnetoencephalography, MEG, and by using stimulation of the brain, transcranial magnetic stimulation. And basically, at the beginning, we used two techniques. One is, at the time, fMRI was really at the very beginning, so we used the PET, positron emission tomography, and we used transcranial magnetic stimulation. With fMRI now, before with PET, it's easy to demonstrate that the same area in humans which code movement are also activated when a person observes another person doing something. And that has been repeated over and over. In the recent review by Kaspers and Ziles, they made a meta-analysis of 100 studies, and they show all the same thing, that parietal lobe and frontal lobe, exactly as in the monkey. So evolutionarily, it remained the same spots in both species. And since we know that motor system is motor, so if it responds to specific type of action, I think it's easy to conclude that the mirror system is present there. The other, maybe even more stronger evidence is with transcranial magnetic stimulation. So if you stimulate, for example, the motor cortex of left side, you see movement of the right hand. Then you decrease the threshold, and there is no activity. Now you are doing the action, and the same stimulus, which was below threshold, now elicits the movement in the observer. So in this case, the same, it's interesting because in this case not movement, but the same muscle. So if you have opponent policies which fire when I do this movement, I observe your movement, the same muscle became active. So that's, I think, it's typical of humans. I don't know about monkey, if the monkey will be so precise. But in humans, we have a kind of other mirror mechanism which is able to code not only the goal, but how the goal has been done. And that's very fundamental for imitation. Because you know the classical definition of imitation, which now all ethologists, is that you repeat something using exactly the same movement of the teacher. It's not only the goal. So I think humans are endowed with two mirror basic mechanisms in the motor system. One for understanding the goal, one for repeated, for imitation. Monkeys don't imitate, so monkeys probably have only one system. So about EEG, maybe is one of the easiest way, because it has been described many years ago by Gaston in France, that there are some rhythm in the motor cortex which react, desynchronize, change their appearance when you move the head. Even if you have your eyes closed, because the posterior, the occipital rhythm change when you open and close the eyes. These neurons, these rhythms change when you move your head. So in Los Angeles, or better in San Diego, Ramachandran and his colleague showed that the same thing happens when you observe somebody. So the same desynchronization is achieved when you do and when you observe. And they concluded that the basis of these are the mirror system. This experiment has been repeated by many people, by Rita Hari in Finland with MEG, by Cochen in France, so by many people. So it's a very simple way to show the reactivity of the motor system to specific type of visual stimuli. The point with now, which the people who work on that, is to find the rhythm which originally has been described as mu rhythm or rhythm en arceau. Actually, probably it's a rhythm formed by different frequency which are placed together, and then why there is this specific rhythm. So the people try to dissect what is really related to mirror system, high frequency, low frequency, and so on. So there is a topic, specific topic, which many people are studying now. The possibility to record in humans is extremely fascinating. And now there are some possibility, because in order to cure some form of epilepsy, the people introduce into the brain of humans several electrodes. Usually they are big electrodes with some spot from which you can record only EEG, another type of activity. But there are some people who put some very tiny wires at the end of this electrode. So from there, they can record single neurons. That has been done, especially in Los Angeles, Jacoboni and Fried, it's the surgeon. And they found some neurons which maybe are mirror neurons. I say maybe because they have some properties of mirror neurons, but they are in areas which we don't know much physiologically, like hippocampus or the cingulate. So they claim they are mirror neurons, maybe they are right. Because if you think that mirror neurons are really neurons endowed with specific mechanisms, maybe these neurons which have more complex property than what we discover in the motor cortex are really have this mechanism. But you know, unfortunately, when you work with a patient, you have a very little time. So in the monkey, I can test a neuron for 1 hour, for 2 hours. In humans, you have a window of few minutes, and these few minutes you have to do the testing, because then, in the acute case. In the chronic case, maybe it's possible to test better. Well, then there is the beautiful case, which is anecdotal, but it's beautiful. It has been done by a neurosurgeon, and he was recording from a cingulate area, which have neurons sensitive to pain. So if he touched it with, I don't know what he has, a pin. Anyway, he makes some pain in the patient, and there was a reaction of a single neuron. And then he repeated the same on himself. So he put this needle on his skin, and there was a discharge of the same neurons, of the same neuron. He was just, he didn't know anything about mirror neurons. He just said, there is this curious thing in the cingulate. I found one neuron which fired both one. I administered some pain stimuli to the patient and to myself.